The sun is so massive that it contains 99.8% of all the mass in our solar system, dwarfing every planet, including Earth. Yet Earth's water, covering 71% of its surface, holds the key to life as we know it. Here's a striking thought. If we poured all of Earth's water onto the sun, it would barely make a ripple. Did you know just how tiny our planet's water is compared to the vastness of the sun? Let's uncover what really happens in this cosmic showdown. The sheer volume of Earth's water. Earth's water is staggering in scale. About 1.4 billion cubic kilometers of it spread across oceans, rivers, lakes, and underground reservoirs. This vast quantity covers around 71% of our planet's surface, shaping climates, ecosystems, and life itself. But when you compare this to the sun, the numbers tell a different story. The sun is a colossal ball of plasma with a volume roughly 1.4 million times greater than Earth's. So even if we could somehow gather every drop of water on Earth and pour it onto the sun, it would be like adding a single teaspoon to an Olympic-sized swimming pool. This comparison highlights just how immense the sun truly is. While Earth's water seems endless to us, it's practically negligible on a cosmic scale. Understanding this contrast not only puts our planet's resources into perspective but also sparks curiosity about how such a relatively tiny amount of water would behave in the sun's extreme environment. This sets the stage for a fascinating exploration of what would really happen if Earth's water met the fiery surface of our nearest star. The sun's enormous scale. The sun isn't just big, it's unimaginably massive. When you hear that the sun's volume is about 1.4 million times that of Earth, it's hard to grasp what that really means. To put it simply, if Earth were the size of a small marble, the sun would be a gigantic beach ball towering over it. This vast difference in scale means that even the entirety of Earth's water, which feels endless to us, is just a tiny speck compared to the sun's sheer size. The sun's enormous volume is made up of scorching hot plasma, a state of matter so extreme it's unlike anything we experience on Earth. This immense size and energy output allow the sun to sustain nuclear fusion, the process that powers its light and heat. So when thinking about pouring all Earth's water onto the sun, it's like trying to fill a massive ocean with a single bucket of water. The sun's colossal scale means that this water would barely make a dent, swallowed instantly by the star's overwhelming mass and energy. This contrast between Earth and the sun's size sets the stage for understanding why such a dramatic idea, pouring all our planet's water onto the sun, would have surprisingly little impact on the star itself, even though it would be catastrophic for life here on Earth. What is the sun made of? The sun is not just a giant ball of fire, it's a swirling mass of plasma, mostly hydrogen and helium, existing in a state that's completely alien to us. About 74% of the sun's composition is hydrogen, with helium making up roughly 24%, and the rest are trace elements. This plasma state means the sun's gases are so hot and energized that electrons are stripped from atoms, creating a soup of charged particles. Unlike the water we're familiar with on Earth, which is liquid and cool, the sun's surface temperature is around 5,500 degrees Celsius, and its core reaches an astonishing 15 million degrees Celsius. In this environment, water molecules can't survive. They would instantly break apart into hydrogen and oxygen atoms. This extreme heat and energy make the sun a nuclear fusion reactor, where hydrogen atoms fuse to form helium, releasing immense energy that powers life on Earth. So when thinking about pouring Earth's water onto the sun, it's important to remember that the sun isn't a solid surface or a cool body of water. It's a blazing, electrified plasmasphere where water can't exist in any familiar form. This fundamental difference in composition and state of matter explains why Earth's water would be completely transformed the moment it touched the sun's atmosphere, setting the stage for what happens next in this cosmic experiment. What happens to water near the sun? Well, water and the sun are a recipe for instant transformation. The moment any water from Earth approached the sun, it wouldn't stay liquid for even a fraction of a second. The sun's surface temperature is about 5,500 degrees Celsius, hot enough to vaporize water instantly. But it doesn't just evaporate like steam from a boiling kettle. The intense heat breaks water molecules apart into their basic elements, hydrogen and oxygen atoms. These atoms then become ionized, meaning they lose electrons and turn into charged particles, blending seamlessly into the sun's already roiling plasma. This process happens so quickly and violently that the water essentially disappears, losing all its original form. Instead of a splash or steam cloud, the water's atoms become part of the sun's fiery atmosphere, carried away by solar winds or absorbed deeper into the star. This extreme environment ensures that Earth's water would never accumulate or create any visible effect on the sun's surface. So, pouring all of Earth's water onto the sun wouldn't cause a dramatic explosion or change. It would be a silent, instantaneous absorption into the star's blazing furnace, highlighting just how hostile and powerful the sun truly is. Would the water affect the sun's composition? Adding all of Earth's water to the sun might sound like it could change the star's makeup, but in reality, it's barely a drop in the cosmic ocean. The sun's mass is about 330,000 times that of Earth, and its composition is overwhelmingly hydrogen and helium. When water, made of hydrogen and oxygen, arrives, it's such a tiny addition compared to the sun's massive volume that it won't noticeably shift the star's elemental balance. The hydrogen from water would simply blend into the sun's existing hydrogen supply, while the oxygen atoms would be quickly ionized and absorbed into the plasma. This means the fusion reactions that power the sun would continue unaffected, as they rely on hydrogen nuclei colliding under immense pressure and temperature in the core. The sun's immense energy output and gravity dwarf any influence Earth's water could have. So despite the dramatic idea of pouring all our planet's water onto the sun, it wouldn't alter the star's composition or behavior in any meaningful way. This highlights the incredible scale and power of the sun compared to our home planet, emphasizing how small Earth's resources are in the grand scheme of the cosmos. Could the oxygen from water cause any reaction? Oxygen might seem like a wild card when it comes to pouring Earth's water onto the sun, but it wouldn't cause any dramatic fireworks. Once water molecules break apart near the sun, oxygen atoms become ionized, stripped of their electrons, and merge into the sun's plasma environment. This plasma is already a chaotic mix of charged particles, so the oxygen simply becomes part of that turbulent sea. Unlike on Earth, where oxygen supports combustion, the sun's extreme heat and pressure prevent any typical chemical reactions. The oxygen atoms don't ignite or explode. Instead, they're absorbed and dispersed by the sun's immense energy and magnetic fields. This means no sudden bursts or new solar phenomena would arise from the oxygen alone. The sun's fusion process, fueled by hydrogen nuclei, remains untouched by this tiny addition of oxygen. So, while oxygen is essential for life on Earth, in the sun's blazing furnace, it's just another particle swept up in the endless dance of plasma and energy. This shows how different the sun's environment is from anything we experience, turning familiar elements into something entirely alien. What about the sun's energy output? So, what about the sun's energy output? Well, the sun's power actually comes from deep within its core, where nuclear fusion transforms hydrogen into helium, releasing immense energy that lights up our entire solar system. This energy output is so vast that honestly, adding Earth's entire supply of water on the sun's surface wouldn't cause any noticeable change at all. The fusion process really depends on conditions in the core, temperatures of around 15 million degrees Celsius and crushing pressure, not on what happens at the surface or in the outer layers. Water, once it's vaporized and broken down, just becomes part of the sun's plasma without affecting the core's reactions. The sun's brightness, heat, and energy output remain steady because they're governed by these internal fusion processes, which are, honestly, far beyond the influence of any external material like Earth's water. So, this means that no matter how much water we pour onto the sun, it won't brighten, dim, or flare up in response. Understanding this really helps us appreciate the incredible stability and power of our star, which just keeps shining brightly, totally unaffected by even the most dramatic additions from our tiny planet. Would this water cause solar phenomena? Solar activity like flares and sunspots might seem like they could be influenced by adding something new to the sun's surface, but Earth's water wouldn't trigger any of these phenomena. These solar events are driven by the sun's complex magnetic fields and plasma dynamics deep within its atmosphere, not by external substances. When water reaches the sun, it's instantly vaporized and broken down into atoms that blend into the plasma without disturbing the magnetic forces at play. The sun's magnetic field lines twist and snap due to internal motions and charged particle flows, causing solar flares and sunspots, processes far removed from any material we might add on the surface. So, pouring all of Earth's water onto the sun wouldn't spark new solar storms or alter existing ones. Instead, the water's atoms would simply become part of the sun's vast, turbulent environment, invisible and insignificant against the backdrop of these powerful magnetic phenomena. This highlights just how dynamic and self-contained the sun's activity is, governed by forces and energies far beyond anything Earth can contribute. Could this water create a visible effect? Any hope of seeing a dramatic splash or cloud when pouring Earth's water onto the sun quickly fades under the star's intense conditions. The water wouldn't linger or create visible effects like steam or mist. Instead, it would be instantly vaporized and broken down into individual atoms, which would then be swept into the sun's seething plasma atmosphere. This process happens so rapidly and thoroughly that no splash, plume, or cloud would form to catch the eye. The sun's surface is a roiling sea of charged particles and magnetic fields, where anything foreign is quickly absorbed and dispersed. So, rather than a spectacular visual, the water's atoms quietly vanish into the sun's fiery environment, becoming part of the endless energetic dance that powers our star. This invisibility of Earth's water on the sun's surface underscores just how extreme and overwhelming the sun's environment is, turning something as familiar as water into an unnoticeable drop in a blazing ocean. Earth's water is precious. Earth's water might seem endless to us, but it's a finite treasure that sustains every form of life on our planet. Losing it all to the sun would mean the complete collapse of ecosystems, agriculture, and human civilization. While it's fascinating to imagine pouring all that water into the sun and watching it vanish, the reality is that Earth's water is irreplaceable and vital. This cosmic thought experiment highlights just how precious and unique our planet's resources are in the vastness of space. The sun, with its immense power and size, remains unaffected by such a small addition. But for Earth, water is the foundation of life, climate, and even our future. Protecting and valuing this resource is crucial because, unlike the sun's endless energy, Earth's water is limited and fragile. So while the idea of sending all our water into the sun sparks curiosity and wonder, it ultimately reminds us to cherish and safeguard the life-giving liquid that makes our world so extraordinary. What other cosmic questions or wild ideas do you want to explore next? Let me know. Thanks for exploring this cosmic journey with Space Facts. If you enjoyed uncovering what would happen if all of Earth's water poured onto the sun, don't forget to hit that subscribe button and ring the bell icon so you never miss an out-of-this-world fact. We love hearing your thoughts, so drop a comment below. What other space mysteries should we dive into next? Keep looking up and stay fascinated. The International Space Station has been orbiting Earth for over 25 years, traveling at a staggering speed of 28,000 kilometers per hour, while hosting astronauts from around the world. It's the largest human-made structure in space, and a symbol of unprecedented international cooperation. But, did you know the ISS was originally designed to last just 15 years? What happens when this iconic space lab reaches the end of its journey? Are you ready to uncover the story behind the end of the ISS? What is the International Space Station? The International Space Station, or ISS, isn't just a giant metal structure orbiting Earth. It's one of humanity's most ambitious collaborations ever. Launched in 1998, this incredible space laboratory has been home to astronauts from around the world, all working together to push the boundaries of science and technology beyond our planet. For over 2 decades, the ISS has circled Earth every 90 minutes, providing a unique platform for experiments that can't be done anywhere else. It's been a place where researchers study everything from human health in zero gravity to the effects of cosmic radiation, and even test new materials and technologies that could one day help us explore deeper into space. More than just science, the ISS represents a symbol of international teamwork, with space agencies from the US, Russia, Europe, Japan, and Canada all contributing to its construction and operation. Despite being originally designed for a 15-year mission, the ISS has far exceeded expectations, serving as a vital stepping stone for humanity's future in space. But as impressive as it is, the station's hardware is aging, and the era of the ISS is approaching its final chapter. Understanding what the ISS is and why it matters sets the stage for why its eventual retirement will be such a significant moment, not just for space exploration, but for global cooperation and scientific progress as a whole. The ISS's lifespan and aging infrastructure. The International Space Station was never meant to last forever. When it was first designed in the 1990s, engineers planned for a lifespan of about 15 years. Enough time to prove that living and working in space was possible on a large scale. But here we are more than 25 years later, and the ISS is still orbiting Earth, a testament to human ingenuity and international cooperation. The truth is, the station's hardware is showing its age. Constant exposure to the harsh environment of space, extreme temperatures, radiation, and micrometeoroid impacts, takes a toll on its structure and systems. Over time, critical components like solar panels, life support systems, and communication equipment degrade, making maintenance more challenging and costly. NASA and its partners have had to send up countless repair missions, replacing parts and upgrading systems to keep the ISS operational. However, there's only so much that can be done when the station's core modules were never designed for indefinite use. As the ISS continues to age, the risk of system failures increases, raising safety concerns for the astronauts living aboard. This aging infrastructure is a major reason why space agencies are now planning to retire the ISS within the next decade. The station has served far beyond its expected lifespan, but the realities of wear and tear, combined with evolving space exploration goals, mean it's time to look toward the future and new platforms that can carry humanity's presence in space even further. Why is the ISS coming to an end? Deciding to end the International Space Station's mission isn't just about old hardware. It's a complex mix of technical challenges, financial realities, and shifting priorities in space exploration. Maintaining the ISS is incredibly expensive, with billions of dollars spent annually to keep it running safely and effectively. As the station ages, these costs only rise, especially since repairs become more frequent and complicated. At the same time, space agencies like NASA are turning their attention to new frontiers, such as the Moon and Mars, which demand fresh investments and innovative technologies. Politically, the ISS has been a beacon of international cooperation, but geopolitical tensions and changing partnerships also influence the decision to retire it. Moreover, the station's design limits how much it can be upgraded to meet the needs of future missions. Private companies are stepping into the spotlight, offering new opportunities for commercial space stations that could take over some of the ISS's roles more cost-effectively. All these factors combined mean that while the ISS has been an extraordinary achievement, it's no longer sustainable or aligned with the next era of space exploration. The decision to retire the ISS is a strategic move to redirect resources and focus on building the future of human presence in space, ensuring that progress continues beyond low Earth orbit. The planned timeline for deorbiting. The final chapter of the International Space Station is already being written, with a carefully planned timeline guiding its eventual retirement. Current projections suggest that the ISS will continue orbiting Earth until around 2031, although some discussions consider extending its life slightly beyond that. This timeline isn't arbitrary. It's the result of extensive analysis of the station's condition, safety concerns, and evolving mission goals. As the end approaches, space agencies will gradually reduce the station's operations, shifting focus to preparing for its controlled deorbit. This process involves meticulous planning to ensure the station re-enters Earth's atmosphere safely, minimizing risks to people and property on the ground. The timeline also allows for the transition of research and activities to new platforms, including upcoming commercial space stations and lunar habitats. While the ISS has been a constant presence in low Earth orbit for over 2 decades, this planned timeline marks a significant turning point in human spaceflight. It's a reminder that even the most impressive engineering feats have lifespans, and that the future of space exploration depends on innovation, renewal, and new beginnings beyond the familiar orbit of the ISS. What happens during deorbiting? When the International Space Station begins its final descent, it won't be a chaotic crash, but a carefully controlled farewell to orbit. Deorbiting the ISS is a complex and precise operation designed to ensure safety for everyone on Earth. The plan involves gradually slowing the station's speed using specially equipped spacecraft, allowing it to descend through the atmosphere over several hours. As it re-enters, most of the massive structure will burn up due to intense heat from friction with the atmosphere, creating a spectacular fiery display visible from the ground. However, some larger pieces won't completely disintegrate and will fall into a remote area of the ocean, often referred to as the spacecraft cemetery in the South Pacific, far from populated regions. This controlled process is essential because the ISS weighs nearly 420 tons, and an uncontrolled re-entry could pose serious risks. The deorbiting will mark the end of an era but also demonstrate the incredible precision and responsibility involved in managing human-made objects in space. This final act will be watched closely by scientists and space enthusiasts worldwide, a poignant reminder of the station's legacy and the careful stewardship required as humanity transitions to new chapters in space exploration. The role of private companies and new space stations. The future of low Earth orbit is shifting from government-led missions to a new era dominated by private companies and commercial space stations. As the International Space Station approaches retirement, several private ventures are racing to fill the gap, promising to revolutionize how we live and work in space. Companies like Axiom Space and Blue Origin are developing their own space habitats, designed not only for research but also for tourism, manufacturing, and even entertainment. These commercial stations aim to be more flexible and cost-effective than the ISS, opening space access to a broader range of users beyond just astronauts and scientists. This shift reflects a broader trend in the space industry, where innovation is driven by private investment and entrepreneurship, accelerating progress faster than ever before. Governments are partnering with these companies, providing support while focusing their resources on ambitious deep space missions, such as returning humans to the Moon and eventually reaching Mars. The rise of private space stations also promises to create a vibrant space economy, with new jobs, industries, and opportunities that were once unimaginable. In this way, the end of the ISS isn't just a farewell, it's the dawn of a commercial space frontier, where humanity's presence in orbit becomes more dynamic, diverse, and sustainable than ever before. Scientific legacy of the ISS. The International Space Station has been a powerhouse of scientific discovery, transforming our understanding of life both on Earth and beyond. Over its more than 2 decades in orbit, the ISS has hosted thousands of experiments that simply couldn't be done anywhere else. From studying how the human body adapts to microgravity to testing new medical treatments, the station has provided invaluable insights that improve healthcare on Earth. It has also been a testbed for cutting-edge technologies like advanced water recycling systems and materials designed to withstand harsh space environments, innovations that could one day support long-duration missions to the Moon or Mars. The microgravity environment allows scientists to observe phenomena in ways impossible on Earth, revealing new details about fluid dynamics, combustion, and even fundamental physics. Beyond pure science, the ISS has helped prepare astronauts for future deep space exploration by studying the psychological and physical effects of living in space for extended periods. This legacy of research and innovation has laid the groundwork for humanity's next giant leaps into the cosmos. As the ISS nears the end of its mission, its scientific contributions remain a testament to what international collaboration and curiosity can achieve when we reach for the stars together. International cooperation and political impact. The International Space Station stands as one of the most remarkable examples of international cooperation in history. For more than 2 decades, space agencies from the United States, Russia, Europe, Japan, and Canada have worked side by side, overcoming political differences to maintain a shared presence in orbit. The ISS isn't just a scientific lab. It's a symbol of what humanity can achieve when nations unite toward a common goal. This collaboration has fostered trust, knowledge exchange, and peaceful partnerships in a realm often dominated by competition. However, as the station nears retirement, questions arise about the future of such cooperation. The ISS has set a high bar, but geopolitical shifts and emerging space powers mean that future projects will face new challenges. Still, the legacy of the ISS reminds us that space exploration can bridge divides and inspire global teamwork. Its retirement will mark the end of an era, but also the beginning of new international partnerships, as countries and private companies explore fresh ways to collaborate beyond Earth. The story of the ISS is a powerful reminder that space is not just about technology, it's about people coming together to push the boundaries of what's possible. What comes after the ISS? The end of the International Space Station doesn't mean the end of human presence in space, it's just the beginning of a bold new chapter. NASA and its partners are already setting their sights beyond low Earth orbit, with ambitious projects like the Lunar Gateway taking center stage. The Gateway will be a small, crew-tended space station orbiting the Moon, serving as a staging point for astronauts preparing for lunar landings and eventually missions to Mars. Unlike the ISS, which circles Earth, The Gateway will enable longer-duration missions deeper into space, testing technologies and life support systems critical for exploration beyond our planet. Alongside this, other countries and private companies are developing their own space habitats, expanding humanity's reach and capabilities. These next-generation stations will be more specialized, supporting scientific research, resource utilization, and even commercial activities on the Moon and beyond. The transition from the ISS to these new platforms marks a shift from Earth-centric orbit to a more expansive, multi-destination presence in space. It's a thrilling evolution that promises to unlock new discoveries, inspire innovation, and pave the way for humans to become a truly interplanetary species. The end of the ISS is not a farewell, but a stepping stone toward humanity's future among the stars. Why the ISS still matters today. The International Space Station remains one of humanity's most extraordinary achievements, and its importance continues right up to its final days. Even as plans unfold for its retirement, the ISS still serves as a vital platform for scientific research, technology testing, and international collaboration. It's a unique environment where experiments in microgravity help us understand everything from disease mechanisms to new materials, with direct benefits for life on Earth. Beyond research, the ISS inspires millions worldwide, fueling curiosity and passion for space exploration. Its presence reminds us that space is within our reach, encouraging the next generation of scientists, engineers, and explorers. The station also acts as a critical training ground, preparing astronauts for the challenges of longer missions to the Moon, Mars, and beyond. While its retirement marks the end of an era, the ISS's legacy will continue to influence space exploration for decades. It's a bridge between past achievements and future ambitions, proving that international teamwork and human ingenuity can overcome the toughest challenges. As we look ahead to new space stations and deeper missions, the ISS still matters, serving as a beacon of what we've accomplished and a foundation for what's yet to come. Its story is far from over, and its impact will resonate long after it leaves orbit. Thanks for joining us on this journey through the incredible story of the International Space Station. If you enjoyed diving into the past, present, and future of humanity's home in orbit, don't forget to hit that subscribe button and ring the bell icon so you never miss a Space Facts update. We'd love to hear your thoughts. Drop a comment below and tell us what amazed you most or what space topics you want us to explore next. Until next time, keep looking up and stay curious. Mars is closer to becoming humanity's second home than ever before. In the year 2025, multiple missions are actively exploring the planet, uncovering secrets that could change everything we know about life beyond Earth. Here's a powerful fact. Mars has the tallest volcano in the solar system, Olympus Mons, standing nearly 3 times the height of Mount Everest. This giant peak tells a story of a planet shaped by intense geological forces. Did you know this incredible feature exists on our neighboring world? Mars missions in 2025. Mars in 2025 is no longer just a distant dream but a dynamic frontier buzzing with activity and innovation. This year marks a pivotal moment as multiple missions, both robotic and preparatory for human arrival, are in full swing. NASA's Perseverance rover continues to send back invaluable data, analyzing Martian soil and searching for signs of ancient microbial life, while China's Tianwen-1 mission expands our understanding of Mars's atmosphere and surface. Meanwhile, private companies like SpaceX are pushing the boundaries with their Starship program, aiming to make human travel to Mars a reality within the decade. Advances in artificial intelligence and robotics have revolutionized how these missions operate, allowing rovers and landers to perform complex tasks autonomously, overcoming the communication delays between Earth and Mars. The year 2025 also sees unprecedented international collaboration, with agencies from Europe, Russia, and the UAE joining forces to share resources and expertise, accelerating our collective progress. These missions not only gather scientific data, but also test new technologies for sustainable living on Mars, such as habitat modules and life support systems designed to withstand the harsh Martian environment. The excitement is palpable because each discovery brings us closer to answering profound questions about life beyond Earth and our future as an interplanetary species. Mars in 2025 is a testament to human curiosity and determination, setting the stage for the next giant leap in space exploration. What's happening on the Red Planet right now isn't just history in the making, it's the foundation for humanity's future among the stars. Technological advances. The technology powering Mars exploration in 2025 is nothing short of revolutionary, transforming how we study and prepare for life on the red planet. Gone are the days when rovers were simple remote-controlled machines. Today's explorers are equipped with cutting-edge artificial intelligence that enables them to make decisions independently, navigate treacherous terrain, and conduct experiments without waiting for instructions from Earth. This leap in autonomy is crucial because the communication delay between Earth and Mars can stretch up to 22 minutes one way, making real-time control impossible. Advanced robotics now handle complex tasks like drilling beneath the surface to collect samples, analyzing soil chemistry, and even assembling habitat components designed for future astronauts. Communication technology has also seen a massive upgrade, with laser-based systems promising faster and more reliable data transmission, allowing scientists to receive high-resolution images and detailed findings almost in real time. Additionally, innovations in power sources such as improved nuclear batteries and solar panels optimized for Mars's dusty environment ensure these missions can last longer and perform more ambitious tasks. The integration of virtual reality and augmented reality tools is also helping mission planners and engineers on Earth to simulate Mars conditions with incredible accuracy, refining every step before it happens millions of miles away. All these technological advances don't just push the boundaries of exploration, they lay the groundwork for sustainable human presence on Mars. In 2025, technology isn't just supporting missions, it's redefining what's possible for humanity's next giant leap into the cosmos. Mars colonization efforts. Human colonization of Mars in 2025 is shifting from science fiction to serious groundwork, with bold plans and groundbreaking tests shaping the future of interplanetary living. SpaceX's Starship program is at the forefront, making rapid progress toward carrying the first humans to Mars within the next few years. These efforts are not just about reaching Mars, but about creating sustainable habitats where people can live and work long-term. Engineers and scientists are testing life support systems that recycle air and water, advanced greenhouses to grow food in Martian soil, and radiation shielding to protect settlers from cosmic rays and solar storms. NASA's Artemis program, while focused on the Moon, is also playing a crucial role by developing technologies and strategies that will be adapted for Mars missions. Meanwhile, space agencies worldwide are collaborating on building infrastructure like landing pads, communication networks, and energy sources that future colonies will rely on. The challenges are immense. Mars' thin atmosphere, extreme temperatures, and isolation demand innovative solutions. But every test and prototype in 2025 brings us closer to turning Mars into a second home. What's thrilling is that this isn't just about astronauts in spacesuits. It's about creating a new society, with all the complexities that come with it, from psychology to resource management. The dream of humans living on Mars is no longer a distant fantasy, but a rapidly approaching reality, fueled by relentless ambition and cutting-edge science. In 2025, Mars colonization efforts are laying the foundation for humanity's boldest adventure yet. Scientific discoveries. Mars continues to surprise scientists in 2025 with groundbreaking discoveries that, honestly, reshape our understanding of the planet's history and its potential for life. Recent data from rovers and orbiters have revealed these really complex geological formations that hint at a wetter, more dynamic past than we ever imagined. Sedimentary layers, ancient riverbeds, and mineral deposits all suggest that Mars once had vast oceans and lakes, creating environments that could have supported microbial life. In 2025, researchers are analyzing organic molecules found in Martian soil samples, and that's sparking some lively debates about whether life ever existed there. These findings aren't just scientific curiosities, they could actually answer one of humanity's oldest questions: are we alone in the universe? Additionally, the discovery of methane spikes in the atmosphere continues to intrigue experts, since methane can be produced by both geological and biological processes. Figuring out its source could unlock clues about current or past life beneath the surface. Mars's diverse terrain, from those towering volcanoes to deep canyons, is also being studied in unprecedented detail, revealing how volcanic activity and climate shifts shaped the planet's evolution. Each new discovery adds pieces to the puzzle, helping scientists prepare for future human missions by identifying safe landing sites and resource-rich areas. The excitement in 2025 is honestly palpable, because every breakthrough brings Mars closer from a distant world to a place we might actually one day call home. Exploring Mars isn't just about science, it's about discovering our own origins and possibilities in the vast cosmos. Water on Mars. Water on Mars has become the hottest topic in 2025, and for good reason. Finding accessible water is the key to unlocking Mars's potential for life and human settlement. Recent missions have confirmed that vast reserves of water ice lie hidden beneath the planet's surface, especially near the poles and in some mid-latitude regions. But what's truly exciting is the growing evidence that liquid water might occasionally flow on the surface, even if just briefly, during those warmer seasons. This discovery really challenges long-held beliefs about Mars being a completely dry world, and it opens up new possibilities for sustaining future explorers. Scientists are also investigating how to extract this ice efficiently, turning it into drinkable water, breathable oxygen, and even rocket fuel by splitting water molecules. This could drastically reduce the need to transport resources from Earth, making Mars missions a lot more feasible and cost-effective. Moreover, understanding the water cycle on Mars helps researchers predict weather patterns and seasonal changes, which is crucial for planning safe human activities. The presence of water also fuels the ongoing search for microbial life, since water is essential for all known life forms. In 2025, every drop of water discovered on Mars isn't just a scientific breakthrough, it's a lifeline for humanity's ambitions beyond Earth. With water now more than just a distant hope, Mars is steadily transforming from a barren desert into a world teeming with potential for discovery, survival, and maybe one day, thriving human communities. Mars atmosphere and climate. Mars's atmosphere in 2025 remains one of the most fascinating and challenging aspects of exploring the red planet. Unlike Earth's thick, life-supporting blanket of gases, Mars has a thin atmosphere composed mostly of carbon dioxide, with just traces of nitrogen and argon. This thin layer means surface pressure is less than 1% of Earth's, making it impossible for humans to breathe without assistance. But what's really captivating in 2025 is how scientists are unraveling the mysteries of Mars's climate and weather patterns. Dust storms, some of which can actually engulf the entire planet for weeks, continue to pose a major obstacle for solar-powered missions and future colonists. These storms can drastically reduce sunlight, affecting energy supplies and visibility. Researchers are closely monitoring temperature fluctuations that swing wildly from blistering heat during the day to freezing cold at night, demanding innovative solutions for habitats and equipment. Recent data also show seasonal changes in atmospheric gases, hinting at active geological or even biological processes beneath the surface. Understanding these atmospheric dynamics is absolutely crucial for planning safe landings, designing protective gear, and predicting weather conditions for astronauts. In 2025, every insight into Mars's atmosphere brings us closer to taming this alien environment, turning a hostile world into a place where humans might one day thrive. The red planet's climate may be harsh and unpredictable, but it's also a puzzle that fuels our curiosity and determination to explore further. International collaboration. International collaboration on Mars exploration in 2025 is reaching unprecedented levels, proving that space truly unites humanity beyond borders. Space agencies from Europe, Russia, China, the UAE, and the United States are pooling their expertise, technology, and resources to tackle the immense challenges of reaching and studying Mars. This global teamwork accelerates progress by sharing data, coordinating mission schedules, and jointly developing new technologies. For example, the European Space Agency's ExoMars mission works closely with NASA's Perseverance rover, combining their scientific instruments to maximize discoveries. Meanwhile, private companies from various countries contribute innovative spacecraft designs and launch capabilities, making Mars missions more affordable and frequent. This cooperation extends beyond just hardware. Scientists and engineers across continents collaborate in real time through virtual platforms, analyzing samples and planning future missions together. The benefits are clear. By working as a united front, the international community can overcome technical, financial, and logistical hurdles that would be insurmountable alone. In 2025, Mars exploration is not just a race, it's a shared journey that reflects humanity's collective curiosity and ambition. This spirit of collaboration also sets a powerful example for solving Earth's problems, showing how global challenges can be met with unity and innovation. As we push further into the cosmos, the partnerships forged today will be the foundation for sustainable human presence on Mars and beyond. The story of Mars in 2025 is as much about cooperation as it is about discovery, reminding us that when we reach for the stars, we do it together. Challenges in Mars exploration. Mars exploration faces some of the toughest challenges humanity has ever encountered, and well, 2025 is no exception. One of the biggest hurdles is radiation. Without Earth's protective magnetic field, astronauts and equipment on Mars are exposed to dangerous cosmic rays and solar particles that can damage DNA and electronics. Engineers are, racing to develop effective shielding technologies, from advanced materials to underground habitats, to keep future settlers safe. Another persistent challenge is Mars's infamous dust storms, which can last for weeks and cover the entire planet, blocking sunlight and disrupting solar power systems. These storms also pose risks to machinery by clogging joints and sensors with fine dust. Communication delays between Earth and Mars, which can stretch up to 22 minutes one way, make real-time control impossible, forcing rovers and landers to operate autonomously, a complex feat requiring sophisticated AI. The thin atmosphere and extreme temperature swings, from scorching days to freezing nights, demand robust life support systems and habitat designs that can withstand these harsh conditions. Even the psychological effects of isolation and confinement on astronauts are a major concern, prompting research into mental health support for long-duration missions. Despite these obstacles, every challenge tackled in 2025 pushes us closer to sustainable human presence on Mars. These difficulties don't just test technology, they test human resilience and ingenuity, proving that with determination and innovation, no frontier is too daunting. Mars exploration in 2025 is a story of overcoming the impossible, one challenge at a time. Mars sample return missions. Mars sample return missions in 2025 are among the most ambitious and eagerly anticipated projects in space exploration. For the first time, robotic spacecraft are not only collecting soil and rock samples, but preparing to send these precious pieces of Mars back to Earth for detailed analysis. This monumental effort involves complex coordination between orbiters, landers, and rovers working in perfect harmony. The samples hold the key to unlocking Mars's secrets, offering clues about its geological history, climate evolution, and the tantalizing possibility of past life. Unlike remote analysis, bringing Martian material to Earth allows scientists to use the most advanced laboratory equipment, far beyond what can be sent to Mars, to conduct experiments with, honestly, unparalleled precision. The technical challenges are enormous. The spacecraft must safely collect, store, and launch the samples into orbit around Mars, where another spacecraft will capture them for the journey home. Success in 2025 would mark a historic first in interplanetary sample return, paving the way for future missions that could bring back even more diverse materials. This mission also tests technologies essential for human exploration, such as precision landing and autonomous rendezvous in space. The excitement surrounding these missions is palpable because they represent a giant leap in our quest to understand Mars not just as a distant world, but as a place that once might have harbored life. In 2025, the dream of holding a piece of Mars in our hands is closer than ever, promising to revolutionize planetary science and inspire generations to come. Future outlook beyond 2025. Mars exploration beyond 2025 is shaping up to be an era of bold ambitions and groundbreaking breakthroughs that could, really redefine humanity's place in the cosmos. Plans are already underway for more advanced missions that aim not just to visit Mars but to establish a lasting human presence. Concepts like building self-sustaining colonies, mining Martian resources, and even terraforming parts of the planet are moving from theoretical discussions to serious research and development. Space agencies and private companies are designing next-generation spacecraft capable of faster travel, larger payloads, and safer landings. Technologies tested in 2025 will evolve, enabling astronauts to live longer on Mars, with minimal reliance on Earth. Beyond technology, the focus will shift to creating the social, psychological, and economic frameworks needed for life on another planet. Everything from governance and communication to education and healthcare in space. Meanwhile, robotic explorers will continue to scout new regions, searching for resources and uncovering Mars' secrets in greater detail. International cooperation is expected to deepen, with joint missions and shared infrastructure becoming the norm. The challenges remain daunting: radiation, dust storms, and the sheer distance from Earth. But the momentum built in 2025 promises a future where Mars is not just a destination but a new home. The excitement lies in knowing that what we start now will shape the next century of exploration and discovery. Mars Beyond 2025 is a story of human resilience, innovation, and the unyielding desire to explore the unknown, pushing us ever closer to becoming an interplanetary species. Thanks for joining us on this incredible journey through Mars in 2025. If you loved diving into these fascinating facts about the Red Planet, don't forget to hit that subscribe button and ring the bell icon so you never miss an update from Space Facts. We want to hear from you. Drop a comment below sharing your thoughts or questions about Mars and space exploration. Your curiosity fuels our mission to bring the universe closer to you. Stay curious, and we'll see you in the next video. In 1610, Galileo saw Saturn, but he didn't understand it. His telescope showed strange ears, not knowing they were icy rings that would puzzle humanity for centuries. Today we know those rings are vast, delicate, and possibly vanishing before our eyes, a cosmic masterpiece, fading in silence. Scientists think a lost moon or a celestial collision may have created them. But we still ask, why Saturn? Why not the others? If you stood beneath those radiant bands, would you feel awe or sorrow for what's slipping away? Let's explore the truth behind Saturn's vanishing crown. The enigmatic beauty of Saturn's rings. If you were standing on the surface of one of Saturn's moons, you'd see something that almost doesn't look real. Towering arcs of shimmering ice stretching across the sky like a celestial ribbon. For centuries, this sight has mystified stargazers and astronomers alike. Saturn's rings aren't just decoration, they're clues. Clues to a violent cosmic past, to the invisible forces that shape our universe, and to the kind of beauty that only space can sculpt. But what's wild is that when Galileo Galilei first saw them in 1610, he had no idea what he was looking at. His telescope was primitive, and to him, Saturn looked like it had ears. It wasn't until decades later that scientists realized these weren't ears or wings, but rings. Massive, flat rings made of something far more fragile than rock: ice. Not one single ring but thousands of tightly packed ringlets spanning hundreds of thousands of kilometers. They're wide enough to stretch nearly the distance from Earth to the Moon, but they're razor thin, barely 10 to 30 meters thick in most places. So, why do they exist at all? Why Saturn and not Jupiter or Uranus in the same way? That's where things get fascinating. Let's break it down. What Saturn's rings are really made of. Most people think Saturn's rings are solid, like a giant hula hoop floating in space, but that couldn't be further from the truth. These rings are made of billions, yes, billions of tiny particles, each orbiting Saturn independently. They range from microscopic dust grains to house-sized boulders, and they're mostly composed of water ice, which explains why they reflect sunlight so brilliantly. But here's the twist: they aren't pure ice. Hidden among the icy debris are specks of rocky material and organic compounds. That's right, some of the same carbon-rich molecules that may have played a role in forming life on Earth are found in Saturn's rings. Scientists think the difference in ring color, some being brighter, others darker, might be due to the varying amounts of this dusty contamination. And while they look smooth from afar, the rings are more like a cosmic traffic jam up close. These particles constantly collide, clump together, and break apart again. It's chaos, but organized chaos ruled by gravity. Every motion, every gap between rings is shaped by Saturn's moons tugging on the particles like invisible hands sculpting art. And that chaos may hold the key to how the rings even got there in the first place. How did Saturn's rings actually form? A moon torn apart. That's one of the most widely accepted theories behind the formation of Saturn's rings. Sounds brutal, right? And it was. Scientists believe that long ago, Saturn may have had a large icy moon that drifted too close, within the planet's Roche limit, a point where Saturn's tidal forces became stronger than the moon's own gravity. The result? The moon was literally shredded into pieces. But that's just one version of the story. Another theory is even more chaotic. What if two moons collided at high speed, turning into a spray of debris that spread around Saturn like a slow-motion explosion in space? Over time, gravity helped those icy fragments settle into the thin structured rings we see today. This theory is supported by how flat and disc-like the rings are, just like the aftermath of a spinning cosmic smash-up. Some scientists even think these rings could be the remnants of material that never formed into a moon at all, a frozen ghost moon that failed to become whole billions of years ago. But here's the catch. No matter the theory, one thing remains clear: the rings are a result of destruction. Something had to break, rip, or explode for them to exist. Saturn's beauty is born out of cosmic violence, and that makes it even more incredible. Are Saturn's rings old or surprisingly young? You might assume Saturn's rings have been around forever. After all, the planet itself is over 4.5 billion years old. But what if I told you that the rings might be younger than the dinosaurs? That's right. Some scientists now believe that Saturn's rings may have formed as recently as 100 million years ago, when T-Rex roamed Earth. That's practically yesterday on a cosmic timeline. How could something so massive be so young? It all comes down to their brightness. The rings are incredibly reflective, meaning they haven't been exposed to space dust and debris long enough to darken over billions of years. On the flip side, there's a competing theory that says we've just gotten lucky. Maybe the rings really are ancient, but their icy particles constantly recycle themselves, colliding, breaking down and reforming, keeping them looking fresh and clean despite their age. Cassini's mission tried to settle the debate, measuring how much ring material is falling into Saturn's atmosphere. The data leaned toward a shorter lifespan, meaning we may be living in a rare moment in time when Saturn is dressed in her finest. Either way, the rings are temporary. Whether they're ancient or newborn, they won't last forever. We're witnessing a fleeting masterpiece, and most of the universe won't even get the chance. What NASA's Cassini mission uncovered about the rings. One spacecraft got closer to Saturn's rings than anything in human history, and it changed everything. NASA's Cassini mission, launched in 1997, didn't just orbit Saturn, it danced through its rings, it flew between them, and what it saw was astonishing. Cassini revealed that the rings aren't uniform at all. They're full of waves, literal ripples caused by gravitational tugs from Saturn's dozens of moons. These waves aren't just beautiful, they act like seismic maps. They help scientists understand Saturn's interior structure, the same way earthquakes help us understand Earth's core. Wild, right? And then there were the propellers, tiny gaps carved by moonlets no bigger than a city block. These baby moons move like little shepherds, pulling and pushing ring particles, leaving trails behind like ships through ice. It's a whole ecosystem of motion. Collisions, orbits, spirals, all governed by gravitational forces we can't see but Cassini could feel. What stunned scientists most was the sheer level of detail. They found sharp edges, sudden gaps, and braided structures like strands of hair woven by the cosmos itself. Saturn's rings aren't just pretty, they're alive with motion. Cassini didn't just observe them, it revealed a complex, dynamic system still evolving before our eyes. Will Saturn's rings eventually disappear? They look eternal, but Saturn's rings are fading. Right now, as you read this, those magnificent ice particles are falling, bit by bit, into the planet they orbit. It's called ring rain, and it's caused by Saturn's magnetic field, pulling charged particles from the rings down into its atmosphere. NASA estimates that each second, tons of ring material is being lost forever. Think about that, a structure hundreds of thousands of kilometers wide, vanishing grain by grain like sand in an hourglass. Scientists now believe the rings could be gone in as little as 100 to 300 million years. In cosmic time, that's a blink. And that means we are alive at one of the rare moments in history when Saturn even has rings this bright and massive. Most other planets don't get this kind of spotlight, we just happen to be born at the perfect time to see it. The rings are like fireworks on a galactic scale, stunning, fleeting, and impossible to ignore. One day future civilizations may only see Saturn as a plain gas giant. No icy crown, no shimmering halo, just a memory left in textbooks and telescopes. And that makes every glance at Saturn now feel a little more sacred. The role of Saturn's moons in shaping the rings. Saturn's moons play an incredibly crucial role in the creation, maintenance, and structure of its rings. These moons act as both sculptors and guardians of the rings, exerting gravitational forces that shape the particles within them. Saturn has over 80 moons, but many of them are especially important for the delicate dance of the planet's rings. Some moons, like Pan and Atlas, are small yet vital to the structure of Saturn's rings. They create gaps, or propellers, within the ring material, where the gravitational pull of the moon pushes particles into a tightly packed structure, while leaving a gap in its wake. These gaps resemble the paths left behind by ships moving through ice, and they help maintain the ring's shape and distribution. The effect is not just visual, but also vital for the dynamic behavior of the ring system. On the other hand, moons like Mimas, Enceladus, and Dione have more indirect roles. They interact with the rings by generating gravitational waves, small fluctuations that ripple through the material, organizing it into neat, concentric bands. These waves influence the ring particles' movement and maintain their organized chaos. Through their gravitational interactions, Saturn's moons help to prevent the particles from scattering away into space, ensuring the rings stay intact over millions of years. Interestingly, the material in Saturn's rings is not static, it's in constant motion, constantly being tugged by the moons. This interaction is a prime example of how moons and rings coexist in a delicate balance, with each influencing the other. Without these moons, the rings would likely lack the fine structure and order they currently display. Rather than a simple floating collection of ice, Saturn's rings are a complex, gravitationally controlled system that relies heavily on the nearby moons to sustain its beauty and form. Thanks for joining me on this incredible journey through Saturn's mysterious rings. From icy debris to shattered moons, the secrets they hold are as vast as space itself. There's still so much we don't know, and that's what makes it thrilling. Every new discovery brings us one step closer to understanding the universe we call home. So, what do you think created Saturn's rings? Drop your thoughts in the comments below. Let's start a cosmic conversation. And if you love discovering the secret of the universe, don't forget to subscribe to Space Facts and hit the bell icon for more adventures.